Welcome to section 1.4. In this video, we are going to learn how to multiply and divide fractions. So to multiply fractions, if possible, we're going to do this thing called cross-reducing. And if it's not possible, or once you've done cross-reducing, you're then just going to simply multiply the numerators and multiply the denominators and reduce your final answer if possible. Now to divide fractions, what you're going to do is use this rule called keep, change, flip. And that's where if you're given a fraction, a over b divided by c over d, you're going to rewrite it and keep the original fraction, change the division to multiplication, and flip the second fraction. So c over d changes to d over c. And then, once you do this, the same rules of multiplying fractions apply. So you're going to cross-reduce if possible. Then you're just going to simply multiply the numerators and the denominators together, just like as we've seen up here, and reduce your final answer if possible. All right, so let's get into some example problems. So for example number 1, I'm going to show you, so technically, you don't need to cross-reduce when you're multiplying fractions. So I'm going to show you both ways. I'm going to show you how to multiply fractions when you don't cross-reduce, and I'm going to show you the same example when you do cross-reduce, and then you can kind of compare why we would cross-reduce, because when we cross-reduce, we make our lives a little bit easier, but we'll see why. So let's first do example number 1 without cross-reducing. So I'm going to do that in blue. So I'm going to show this first example. What we're doing in blue is without cross-reducing. So we don't cross-reduce, we're just going to skip step number 1, and we just simply multiply the numerator and denominators together. So what that gets us is we get 1 times negative 3 over 3 times 2. Well, 1 times negative 3 is negative 3, and then 3 times 2 is 6. While this fraction, 3 over 6, notice it's not fully reduced. So we need to reduce this fraction. And notice that we can divide both the numerator and denominator by 3. So negative 3 divided by 3 is negative 1, and 6 divided by 3 is 2. So our final answer is 1/2. I'm going to say this is without CR, cross-reducing. Now, I'm going to show example number 1 with cross-reducing. So, I'm going to do that here with cross-reducing. Okay, so we have 1/3 times negative 3/2. So cross-reducing, what that means is you have to look at the values diagonal to each other. So we have 1/3 and 1/2. That's kind of messy, my apologies. Here, let me rewrite it here. 1/3 times negative 3/2. It's a little bit better. Okay. So you have to look at the values that are diagonal from each other. So we have a 3 and a 3 and a 1 and 2. Now when cross-reducing, you have to ask yourself the question, the values that are diagonal to each other, can I divide, in this case, can I divide 3 and 3 by a common value? In this case, you can. You can divide both 3 and 3 by 3, right? So to cross-reduce, once you recognize that you can reduce two values that are diagonal from each other by a common value, you can cross-reduce. So we can divide 3 by 3, which is 1. And up here, we're going to divide 3 by 3, which is 1. So now that we did that, we have a 1 and a 2, and we can't reduce 1 and 2 any more than they already are. So we're going to keep those as they are. So we're going to do 1 times 1 and 1 times 2. Once you cross-reduce, all you have to do is multiply the numerators and denominators together. So we have 1 times 1, which is 1, and 1 times 2, which is 2. But don't And I repeat, don't forget this negative sign here. We have negative 1/2. Oop, that looks like a plus. Negative 1/2. So notice here, when we didn't cross reduce, we had an additional step. By once we multiply these together, we had to reduce this fraction to get to 1/2. And here, we reduced this fraction and multiplied all in one step. So cross reducing is better, especially this example. Both methods might take about the same time. Cross reducing is still a little bit shorter once you get the hang of cross reducing. But let's say if you're dealing with values that are a little bit larger, for example, example number 3 has larger values, and if you're to multiply directly across this method without cross reducing, it can get a little bit tedious because you're dealing with larger numbers. Anyways, looking at example number 2, I encourage you to pause the video and try this one on your own. And assuming you have given it a go, let's work through it. So because we're multiplying these two fractions, I'm going to first ask myself, can I cross reduce anywhere? Well, I can't cross reduce 7 and 3, but I can cross reduce 2 and 4 because they're both divisible by 2. So I'm going to divide 2 by 2, which is 1, and I'm going to divide 4 by 2, which is 2. And now, because I fully cross reduce, I'm going to multiply 2 by 3 and 7 by 1. Well, 2 times 3, that is 6, and 7 times 1, and that is 7. So your final answer is 6/7. Looking at example number 3, notice we now have division. But not to fright, because division, when you're dividing fractions, it's essentially a division problem in disguise. So recall up here, when you divide fractions, we're going to have to use the rule keep, change, flip. So we're going to keep this first fraction as it is, 21/5. And then we're going to change this division operation to multiplication. And then we're going to flip the second fraction. So 7/10 becomes 10/7. And now we're just going to treat this like a multiplication problem as we were up here. So let's see, because we're multiplying, let's first see if we can cross reduce. Can we cross reduce 5 and 10? We can, because 5 and 10 are both divisible by 5. So 5 divided by 5 is 1, and 5 divided by 10 is 2. But we can also cross reduce 21 and 7. Because 21 is divisible by 7, and 7 is also divisible by 7. So we're going to do 7 divided by 7, which is 1, and 21 divided by 7, and that is 3. And we can't cross reduce. We can't reduce 3 and 1 anymore, 2 and 1. So we'll fully cross reduce, and now we're just going to multiply what we have. So we have 3 and a 2, so we're going to multiply 3 times 2, and we're going to multiply 1 times 1. So 3 times 2, well, that's 6. And then 1 times 1 is 1. So 6/1 is just 6. And that's your final answer. Now looking at example number 4, recall, so we have a mixed number now. So we're going to have to first convert this mixed number and then treat this division problem as we did up here. But I encourage you to pause the video first and try example number 4 on your own. And assuming you have tried it on your own, let's work through it and see if you got it correct. So we're going to have to first convert this mixed number. So we're going to have to multiply 2 times 1, and then we're going to have to add that by 1. So 2 times 1 is 2, and 2 plus 1 is 3. So what this is going to look like is we have 12/8, and we're going to divide that by the mixed number, which now we're converting to an improper fraction, which we said is 3, and then we're going to keep that denominator as 2. So now because we're dealing with division, we're going to do keep, change, flip. So we're going to keep the first fraction, 12/8, change the division to multiplication, and then flip the second fraction. So 3/2 now becomes 2/3. And now because we're multiplying, we have to ask ourselves, well, can I cross reduce anywhere? Let's see. Can I cross reduce 8 and 2? I can, because they're both even, so I can both divide 8 and 2 by 2. So 8 divided by 2 is 4, and 2 divided by 2 is just 1. And now looking at 12 and 3, you can cross reduce both 12 and 3 as well, because 12 is divisible by 3. So 3 divided by 3 is 1, and 12 divided by 3 is 4. Now that we fully cross reduce, let's multiply our numerator and denominators. We have 4 times 1 and 4 times 1. Well, that just ends up becoming 4 over 4. 4 over 4, well, that just equals 1. And that's our final answer. Now, you might be asking yourself, how does this equal 1? Because right here, we're given 2 different fractions, right? Actually, you weren't given 2 different fractions. Here's why. 12 divided by 8. If you reduce 12 divided by 8, when you reduce 12 over 8, you get 3/2. So 12 divided by 8 is the same as 3/2. These are both the same fractions. 3/2 is just the reduced version of 12/8. So that's why you got 1. Because they're the same value. They're the same, both 12/8 and 3/2 are the same value. If you plug this 12 divided by 8 and 3/2 into your calculator, for both of those, you get 1.5. So that's why you get 1. Because 1.5 divided by 1.5 is just 1. All right. Looking at our final example, it looks a little bit different here. We have a whole number, just 10, or negative 10, divided by 15/2. So here's what we're going to do. When this happens, when you get a whole number, we can rewrite negative 10 as negative 10 over 1. And that is because any number divided by 1 is just itself, right? So anytime you're given a whole number when you're dealing with fractions, just write it over 1, because you're not changing the value of it. Negative 10 divided by 1 is still negative 10, so we're not doing anything wrong here. We can write negative 10 over 1, and then we're going to divide that by 15/2. Or 15/12, my apologies. And now we're going to apply all the rules we've seen on the first page. So because we're doing division, we're going to use keep, change, flip. So we're going to keep the first fraction, negative 10 over 1, change it to multiplication, and flip the second fraction. So it becomes 12 over 15. And now, let's see if we can cross reduce. I encourage you to pause the video and see if you can cross reduce on your own if you haven't done so. Now let's work through it. So we have, can we cross reduce 1 and 12? We can't, because we can't reduce 1 and 12 any more than it already is, because we have that 1 here. But we can reduce negative 10 and 15, because they're both divisible by 5. So 15 divided by 5 is 3, and negative 10 divided by 5 is negative 2. So now that we fully cross-reduce, let's multiply the numerator and denominators together. So we get negative 2 times 12, which is negative 24, and then 1 times 3, which is 3. Now, negative 24 divided by 3 is a whole number, actually. And that whole number is negative 8. And that's your final answer.